Hello, Mr. Ferrante here. This is a solution to the first homework problem, and our goal is to solve this equation using algebra tiles, and also to write an equation and solve it using just plain old algebra. So first of all, we have to remember what the legal moves are for this guy. And let's review. There are a few things that you can do. First of all, if you see a zero pair like this, and this is a different problem, but for the purpose of illustrating, this would be a zero pair because you have positive 1 is this blue tile. The red tile is a negative 1, and positive 1 added to negative 1 is 0. 1 minus 1 is 0. So a zero pair will cancel out. Zero pairs can only happen on the same region. You can't cancel, for example, this red can't cancel with this blue because they're not in the same region. So a zero pair is only in the same region of an equation, top to top, or maybe bottom and bottom. That's one legal move. So let's look for some zero pairs inside of our equation. Um, Here in the left-hand top, I don't see a positive or negative x together. I don't see any positive or negative ones. Down here, you can't cancel a 1 with an x. Those are different kinds of tiles. So there's no zero pairs here. And here, we do have a zero pair. Right here, there's a negative x and positive x. So let's circle this negative and positive x and say that that's a zero pair. Those guys cancel out. So for the other problems in the homework, if you see zero pairs, you can go ahead and cancel them out right away. So down here in problem 2, go ahead and look for zero pairs. If you find some in the same region, cancel out your zero pairs first. Same with problem 3 and the rest of them. So back here, let me recircle my zero pair and cancel these guys out. All right, goodbye zero pair. Another legal move that you can do, and back to this example, is since an equation is essentially a balance, so I'm going to put a little triangle down here, and this represents a scale. It's a balance scale that just measures weight on both sides like a seesaw, tips back and forth. If this represents positive 1 pound on this side, and over here, this guy represents positive 1 pound, for a scale, if you had the same weight on both sides and you deleted this 1 pound from each side, the scale would still balance because you're removing the same amount of weight from both sides. That doesn't affect the fact that the scale still balances. So we can remove the same kind of tile from each side of an equation. So back here for our problem, I had my zero pair canceled out. Let me put that back in. These guys canceled out. Do you see any same tiles on each side? Well, we've got a couple of them. We have positive x squared can cancel out with positive x squared because that's the same weight. Also, we have a positive x here can cancel with a positive x on this side. And nothing else matches. These positives, there's no positive x down here. And so if there was one, you could cancel them, but there's not. So I'm going to erase that because there isn't one down here. But you can't cancel these positives down here with the positives up here because they're not directly across from the equation. So be careful when you're canceling. It has to be directly across. All right, we've done our zero pair. We've canceled the same weight on both sides. Another move that we can do is we can flip tiles from one side to the other. So another legal move is flipping tiles. That'd be saying, let's take this tile here and flip it to the top. And when a tile flips over, it gets removed from this side and it flips and changes to the opposite sign. In our case, from a positive blue to a negative red. So flipping tiles is legal, and I'm going to go ahead and do some of that right here. So let's flip these tiles to the top. Let me go back and add my zero pairs. Okay, zero pair we had canceled out. We said an x squared cancels with an x squared, and x cancels with an x, and we said this stuff will flip to the top. So let's flip this over to the top. That will become from two positives, it'll change to two negatives. So there's one negative, and here's another negative. And now those have been taken care of. And this negative x will flip to the top to become a positive x. So let me put this as now a positive blue x. And for me, I'm just going to put blue as positive. I don't need to put a plus sign in front. All right, now let's write the equation we have left over. And you can write the equation from the very beginning. If you want to simplify first, you can write the equation then. I don't really care at what stage you write the equation, but do it sometime before you're done solving. All right, so left over we have 1, 2x's. So we've got 2x. On this side we've got 1, 2, 3, 4, 5 negatives, so minus 5. And then remember this double bar means these sides are supposed to be equal. So the left side equals, on the right hand side we have no more x's, no more x squares, we just have 1, 2, 3, 4, 5 positives. So just 5 positives here. All right, next up, our goal is to solve for x. So by the end, we want to have x by itself equals some number over here. So to get to this goal, we need to get the x's on one side, and we already have that. There's no x's over here, so x has already been isolated. But we need to get this 5 and flip the 5 to this side. With tiles, that means this. We've got 1, 2, 3, 4, 5 negative tiles here. Let's flip these tiles over to this side. So I'm going to go ahead and cancel out these 5 negative tiles from this side and flip them over to this side to become positives, because they used to be 5 negatives. So 1, 2, 3, 4, 5, and they're all positive. Put in plus signs in all of them. Now I've got a total of 10 tiles here. Well, with our equation, we can do the same thing. Take this negative 5 and flip it to this side to become positive 5. And now I've got 10 here equals 2x left over on this side. And this matches what we have here. We have 2 x's. 1, 2. And we have 10 positive tiles. Count those up. There's 10 of them, including this guy. And now, at the end, we can solve mentally and say that if 2 x's are worth 10, that means 2 times some number is 10. Well, it's 5, so you can just say it's 5. From pre-algebra, I'm assuming you've solved equations before. And so to get rid of this 2, since it's 2 times x right now, let's divide 2 to both sides. That way 2 divided by 2 cancels out, and 10 divided by 2 is 5. So we've got x equals 5 is our final solution. And that matches here. If, let me use green, if 2 x's are worth a total of 10 tiles, that means each x has to be worth 5. And this part over here shows it. So that's problem 1. As long as you're doing tiles and getting that each x is worth 5 over here, you have an equation, and you're also getting the same number left over, then that's verifying that the problem is correct. That's it. Maybe in another tutorial I'll do problem 2 or 3, but for now, that's that. Go ahead and do the problems on your own, and have a great night. Bye.